Today. This is our first live Nuance Tech Talk. I kind of geared it towards anticipating that everybody's going to be watching this on a small screen. So you won't really see any real small text that you have to kind of zoom your eyes in on. Made the pictures a little bit larger, and hopefully it's a little bit more friendly. One thing I didn't think about is I should have put like a little box in the corner, like put your video feed here. So hopefully you're not overlapping too much of the slides. So today we're going to talk about negative staining. Typically when people negative stain, somebody in the lab just says, hey, use uranyl acetate. That's what everybody's always used. That's what we use around here. It's super easy to make, and just go ahead and get your data. But Charlene and I have looked into negative staining as a technique, and really found that there are so many stains out there, and that there are so many different ways of getting your data and doing your sample preparation. So we're going to talk about that today. We'll be tag teaming on these slides. All right. So what we're going to talk about, we'll go over what negative staining actually is, how to negatively stain samples. And then, as I mentioned earlier, there are so many stains out there. So we'll briefly cover kind of some of the more common stains and a couple of the more uncommon stains. And of course, anytime you're doing anything in EM or science, there are always issues that pop up. So we'll go over a couple of those common troubleshooting issues, and hopefully will lead you to get better data. After we discuss negative staining, we want to offer you kind of a safe place to address your questions about lab safety, about COVID, and our protocols going forward. So during the presentation, if you have like an urgent question that really pertains to the topic at hand, to the slide, feel free to put that up in the chat, and we will try to answer that as we can. Otherwise, if you can wait till the end of the presentation during the Q&A session, that would be cool too. We can answer questions whenever. So just want to introduce, if you're new to Northwestern or Nuance, wanted to give us a little slide just to say, hey, this is us, come talk to us. Charlene and I, who are giving the presentation, I have a little introduction slide here. So I'm Eric. My hair is considerably longer than it was in this picture when it was taken earlier this year, or I think late last year. So my office is temporarily in Silverman in B545. My old office in B535 was too crowded to be safe for COVID social distancing. So you'll see there's a whole bunch of posters slapped up on the windows there to give me a little privacy. Just feel free to knock on my door. If you need any assistance, please wear your mask, right? So I'm going to pass it off to Charlene here. So go ahead, Charlene, introduce yourself.
Good morning. Welcome to the Tech Talk. I'm Charlene Wilkie. I've been at Northwestern for more than 10 years. You've probably seen me around. I'm still in the Hogan building on the 5th floor, right next to the JOLTM room. And I guess welcome to negative staining. And my little blurb on it is, if you ever have a chance to work on bacteriophage, jump on it. You won't be disappointed. Back to you, Eric.
Oh, Charlene, I think you're up here.
Sorry, I didn't see it. Move on. Thank you. So, so we're going to kind of start off with what is negative staining, right? Like negative staining is just a procedure which embeds a small biological particle or soft material, which is absorbed onto a transparent substrate on a grid in a thin amorphous heavy metal salt to reveal its ultrastructure in TEM. It is named negative staining because the method of depositing the stain on the sample results in an image that resembles that of a photographic image, or photographic negative. As you can see on this slide, at the very bottom, there's all sorts of things that you can negative stain. It is sometimes used as a preliminary method also prior to moving on to cryo work. It can be very helpful to get you very familiar with your sample before going on to cryo, because cryo is inherently low contrast. So then what is negative staining? And negative staining is a very easy method to learn, and it's very easy to perform. It's quick to use as well, and it doesn't really require a lot of specialized equipment. It's usually just what you have around. The tweezers, grids, stain, plasma cleaner, and filter paper. So then,
yeah, so we promised, I mean, usually we have cookies at these tech talks, right? So sorry, we are offering you virtual cookies today. Maybe when we go back live, we'll be able to give you the real thing. So we just wanted to talk briefly about how, everybody kind of does everything differently. We have cookie recipes, everybody has their own recipe, and everybody, makes pretty good cookies, usually. So Charlene, do you want to talk about how you negatively stain and how you've always done it?
Yeah, so this is one of the things that prompted some of the details in our, for this presentation. I was saying, what I do is I usually use a glow discharge grid, usually Formbar and carbon, sometimes just straight Formbar. I deposit my sample onto the grid, leave it in there anywhere from 36 seconds to 10 minutes, and then I wick it away, do some water washes, and then I do some relatively quick, usually using uranyl acetate. I do some quick deposits and a wick where I just leave just a thin membrane behind, but I usually just leave that last stain on for maybe 30 seconds.
Are you sharing the screen? We are still seeing the cookies.
Yeah. We're going to go into more details later, Rainer. So that's, it's funny because I've always done it differently. I don't wash the salt. Typically what I do is just drop cast the sample for, less than a minute until I have my filter paper ready. I blot that off, and then I stain a couple times with uranyl acetate, let that sit for 4 minutes, and then blot it and let that dry for 4 minutes. So Charlene, have you always done it pretty much the same way?
Well, I generally do. I've learned over the years that I've had to make some adaptations, but yeah, I started doing it that way and that's kind of my go-to way that I always kind of do.
I've just never really questioned it. It was the way I was taught, and this way it's always been done. But I think hopefully as everybody who's watching today, we'll find out that there's a lot better ways or different ways and ways that you can approach this.
Yeah. What Eric does, when we were talking about it, it was just a very eye-opening experience that we were doing so different, and we both had success. Right. This was the other point. So here was how to negative stain samples. So I'm going to go a little bit into talking about the grids. So you generally want to use a grid with a support. Well, you do want to use a grid with a support film. Generally, it's a Formbar with carbon. Sometimes it's just carbon. There are manufacturers that will make varying thicknesses of carbon. Some people will use a graphene oxide. Also, the type of grid may be the material the grid is made out of may have an impact as well, such as moving over to nickel or gold. If you are working with, if you're going to be doing immunolabeling on those grids afterwards, or during the process, that's when it may be necessary to go to an alternative metal. Then usually what you'll do is glow discharge the grids. You're going to glow discharge, or also what's known as plasma cleaning, because you want to get rid of the hydrocarbons on that grid, and it will make your grid more hydrophilic. So there is a little bit of voodoo, a lot of voodoo around EM sample prep in general and working with grids, but even with the glow discharge. So how far in advance do you glow discharge your grids? There are some that have very strong, strict instructions that within 10 minutes of glow discharging, you want to be going on and doing your work. I myself, I can do it 24 hours in advance as generally kind of my window of time. But I have heard of situations where people will do it more than 10 days in advance and still have a successful deposit of sample on their grid. So it is kind of there's a wide range of philosophies, and this is where it comes down to probably that's the way I've always been doing it.
Yep.
So how do you set up, so how do you negative stain? There are, as we're saying, many recipes, many methods. So as I said earlier too, it's a fairly simple setup. But what I like to point out is that when you do have these things, when you have your setup for staining, you want to have everything pretty, you want to have it set up in advance and in pretty close proximity, because things will move very quickly and it will be to your benefit to do that. The image on this in the PowerPoint here is what I would call a setup for the drop method, where you actually have, so let me step back just a second here. So for your setup, what you will want to have is your sample, your wash solution, which is usually DI water, your stain grids, which have been glow discharged, paraffin or a petri dish, a pipetter, but even the pipetter, P10 or P200, if you just have the one. For like your wash solutions, I find I don't have to have a very specific drop size for that. So, but if I'm depositing sample, I may want to have more. But so sometimes you could even use a disposable pipetter. You're going to want a forceps, which is probably negative action forceps and anti-capillary. But again, if you don't have it, that's you will still can have success. Filter paper, and you're going to want to have a grid box for storage. So as I was saying, the image on this in the PowerPoint here is the drop method. So what you're going to do is you're going to take your grid and float it onto the drop of solution, or massage it on the drop of the solution. Again, this is, people do a little bit different. If I were depositing for 5 or 10 minutes, I may, my initial sample, I may leave it on for 10 minutes and remove the forceps, right? But some people maintain the grid in the forceps and do that transferring. So you're gonna go from a drop, wick it, move to a drop, wick it, move to a drop, wick it. Another method is you'd actually leave the your grid in your forceps, and you're gonna apply the drop to the grid and then wick that away. So I was gonna say minimizing handling of forceps, but that's maybe not. So moving on to this slide, which is is still part of the sample prep. One of the things that I think is very, I think this is a very good point. This grid brings up a lot of points, especially even about the slight differences. So the image, I like the image right smack dab in the middle there with the fan of multiple forceps, the negative action, so that then because this is very quickly, you may be doing multiple experiments. And so having a set of forceps can be very beneficial. Also, what I like is the different types of filter wedges and the ways in which they may be used. There's the narrow, very long and narrow for wicking, and then there's those that are bent. And this is somebody that had suggested this, or watched their technique, George. And I like the philosophy about it is that one of them is that you can actually, you would have your solution on your grid, and you're going to come up to if you see the filter paper with the blue drop on the upper right there, you come up to that filter wedge, and then you can you can control your wicking a little bit with your angle that you come at it, as well as when you come onto that filter paper, you will not necessarily crush that crush your grid. And if anybody's worked with some of these grids, they can be so fragile. The filter paper is soft enough that it's going to give, versus this other wicking technique that I believe Eric wants to put in a few words on.
Yeah, sure. So, this slide, just as a brief note in the upper left-hand corner there, if anybody's looking for good grids to use for negative staining, I really like these 300 mesh carbon films. You can get them through EMS. There's the order number right there. It's got a nice small holes, so you're less likely to break the carbon. So sorry, back to Charlene's point. In Charlene's technique on the top, it's really cool how you can, kind of mount the filter paper there with your grid box and blotch your grid. And then you're only handling the grid and not the filter paper. the less anchor points you have, the more anchor points you have, the better and the more steady things are going to be. In my technique at the bottom there, I'm only using these negative action tweezers. I just set them down on the bench, and then I draw my filter paper up the edge of the tweezers, and I try not even to touch the grid, just very, very much on the little tip there. So yeah, we cut these out from filter paper, and I do have like a whole box of little tweezers, so it's my negative stain kit. So you might want to make something like that for yourself if you're going to do a lot of negative staining. All right, so what type of stain do you want to choose, right? So if not uranyl acetate, then what? So in this figure from Sharf et al., you can see that the tobacco mosaic virus was stained with various stains. So ranging from uranyl formate, uranyl acetate, you can see is in D there, so top and bottom, A and D. You can compare those, and they're very, very different, and you're going to get very different results from that. Utilizing different stains, you got gadolinium acetate and samarium acetate. They produce widely varying contrasts and widely varying resolutions. And some may or may not be disruptive to your sample itself. So you want to take that into consideration as well. There's other variables in there, pH and so forth. All right, so Charlene has worked a lot with uranyl acetate and uranyl formate. So she's going to cover that topic here.
So uranyl acetate, which a lot of people are using uranyl acetate, again, because I think we've said this is what somebody else has been using in our lab. This is what they taught me. And so I just stay with it. It's also very easy to make up, and it can be made in advance. And so therefore it's readily on hand. And even though it has a low pH and therefore may denature biological materials, the rate at which this happens is often not considered a deterrent, but it's something that you want to be take into consideration. This may be an important point for your sample. But it's, it's a very nice, straightforward stain to use. Yeah, the high electron density does lend to really nice contrast in the TEM. Now, uranyl formate, I first moved over to uranyl formate when I was working on some bacteriophage. And I asked George Lesser for some guidance in using it because it is a tricky stain to use in comparison to uranyl acetate. You must use degassed water in order to make it up. It can break very easily when you're adding your potassium hydroxide. It does have to be used the same day, and you can store it in small aliquots at the -20 degrees, but I've had mixed success with that. But let me tell you, the trade-off of that grain size, it's just for the superior morphology that you can distinguish with the uranyl formate. It's one that I have been using much more frequently. And there was, I can't remember, I thought I wanted to make some, yeah, well, anyhow, but you can actually kind of really see in this comparison, I feel like this is not a completely fair image for uranyl acetate because it isn't actually a very nice stain. But you actually can really see some of the higher resolution. This are actually the same sample. I was really having some challenges with the sample. The client had some very strong expectations of what he should be able to resolve from it. And when using uranyl acetate, I was finding the sample and I could get some sample sizes, but I could not resolve these smaller details that he was looking for. You can see on the right that uranyl formate really was worth that extra step or going through that process that you have to do for using it.
Okay, so as we mentioned, there's a lot of other stains out there. I'm a big fan of phosphotungstic acid, PTA. This is another stain that's very easy to make. You can titrate it to very, very low pH and get vastly different results. It's considered sort of a positive stain. it does stain negatively as well, but it can play some role in changing what you see. You want to be careful with it because it can disrupt membranes. And another advantage of it, though, is it is less likely to precipitate. Obviously, it's not as low or as high of a Z as uranium, so we're not going to see as much contrast. So in this image on the right, you can see from a very recent paper, they're imaging COVID. So with the phosphotungstic acid, we're able to really get into there and see some finer detail, especially when the image is slightly defocused. You can make out the stalk that connects the peplimer to the viron surface. All right, so ammonium molybdate is another stain that's very interesting because it's a bit more osmotically sensitive for samples. So you can kind of play around with it a bit more with biological materials. Again, this one's really easy to make. You just mix it up. You just want to be careful when drying. You can form some crystals, but it has a generally pretty low background. In this image on the right, so this is from a paper where they utilized ammonium molybdate to negatively stain cryo-TEM. So the protocol they followed here was that they drop cast about 4 microliters of their sample onto the grid, and then they floated the grid onto a 100 microliter droplet of 16% ammonium molybdate. That was then quickly blotted and plunged into liquid ethane. So you can see they were able to get much better resolution and much better contrast utilizing this technique with cryo-TEM. Moving on to methylamine tungstate. So this is a commercially available negative stain. So you can get it through nanoprobes. The authors of this paper wrote that the strategy yielded high contrast with fine detail and very little non-specimen background. So they really wanted to take a look at this bacteria that's associated, plays a role with cystic fibrosis. So it doesn't offer as high a contrast as uranyl acetate, and when you're working with really big bacteria, that's actually a good thing because they can sometimes just look straight up, just nothing, just black and white. And again, it's not quite as aggressive as phosphotungstic acid. It doesn't damage the delicate structures as much. Another commercially available stain, Nanovan, which again you can get through nanoprobes. In this image here on the right, they used Nanovan in combination with immunogold labeling. So because it's physiologically compatible, it didn't disrupt the label. And so they were able to use this stain to prove that, hey, their gold is actually working. Their gold labeling is actually working. And then they were able to take that into cryo-TEM and find their proteins and then do their reconstruction. Here we go. Okay, and just to mention, I'm not going to read off all of these, but there are so many other stains out there. And, so you really take that into consideration when you're doing your project. Take a look at the literature for maybe just your specific sample and really figure out what else is used out there besides uranyl acetate. All right, so as I mentioned at the beginning, anytime you're doing something following a protocol, you're going to encounter some issues. So Charlene is going to talk about that here.
Yeah, your challenge could be resolved by changing just any one step, right? I say it takes trial and evaluation. In this image here was comparing this method called flicking, and I thought it was a very interesting that when I first heard of this, so before I go on to the flicking, I want to say, so the charge on your sample, you may end up wanting to change your glow discharging technique. And the timing, something like that, could really have a strong effect on your sample. But with this, we're going to show you a video in just a second here, but before we do, with this flicking method, you'll notice in this image that the small images going across the bottom there, the typical traditional negative staining method produce these globules, but when they use this flicking method, you get these kind of more string-like sample. And I actually have a sample that's been a challenge for me, and I'm considering using this flicking method. And Eric's going to run a Joe video for us demonstrating this.
Okay. All right, we're not going to make you watch the whole thing.
To stain the sample using the flicking method, grip the edge of the grid with a pair of negative pressure tweezers and apply 3 to 5 microliters of sample to the support surface. Holding the tweezers in one hand, angle the grid so that it is at approximately 45 degrees facing away, and rapidly flick the wrist to flick off the majority of the droplet that is on top of the grid. Then, use a glass Pasteur pipette to apply a drop of wash solution to the support surface. Flick off the drop and repeat a few times to wash the sample. Next, apply a drop of staining reagent to the support surface and again flick off the droplet. Repeat this staining step 1 to 3 times depending on the stain depth that is required for visualization of the specimen. Remove excess stain by touching the torn edge of a piece of filter paper to the edge of the grid and then allow the grid to air dry.
All right, so that is from an amazing resource from Joe. There's a great paper on there. We've referred to it twice so far. So I would encourage you to take a look at this Scharf et al. Paper if you're going to do any negative staining.
Other things to consider with the troubleshooting, inconsistent staining, where you get a positive or negative stain effect. This was an interesting one. It's rat tail collagen fibers, and I think this was even on the same grid. So if you, sometimes people, this is where that whole evaluation, trial and evaluation, not just trial and error, don't look at it as trial and error, evaluation is really important in the TEM. And looking around, and that I found that I just had these some very different negative staining results on the same grid. On the next slide, we have this is what I kind of talk about. I think the timing can be really important. Again, using the same techniques. It was both uranyl acetate. I can't remember if these were uranyl acetate or uranyl formate, but either way. It's the same bacteriophage, and you'll notice the image on the left, we kind of have more of a very positive staining event happening there, where the capsid on the bacteriophage really took on that stain, and whereas the image on the right, we have more of that very classic negative stain. It's looking like a photographic negative. The next image, the next troubleshooting we're talking about is that inconsistent staining. Again, where like just because it looks like it's bad, this is what when I'm evaluating, I like to kind of go to dark areas. If you'll notice in the upper left-hand corner of this image, it's pretty dark, and also you'll notice the ultrastructure of the actual the sample it's really soft, and as you move away from that dark stain, you can start to get more of the result, more resolution, or you resolve more unique attributes of the sample in that. And then as you move further away, you have no contrast at all because of the staining, the way the stain, there's not enough of it. So again, using that evaluation, and also looking, don't be afraid to look at areas that initially look bad to you. Then we also have an image of like, what is this on my slide? It's these are salts. So sometimes, you know, depending on the buffer or the the staining solution, the washing steps, you kind of want to watch that carefully. So you may actually have to develop some salts. And this is where pH can really make a difference, either in your sample, your carrier, and your stain. And Eric has a couple of comments that he has some things he wants to show you regarding pH.
Yeah, sure. Buffer salts can be really pretty to look at. They're distracting because you can confuse them for your sample sometimes, but just take that into consideration. So another thing to take into consideration, when you're planning your experiment is the pH of your negative stain. And it can have vastly different outcomes on your data. So in this paper here, they took a look at gold nanoparticles that were coated with a polymer shell. In one, we can see there's no staining. And in row 2, they used the traditional uranyl acetate, and you really don't see anything. It wasn't until they switched to phosphotungstic acid at a very low pH that they actually got the structure that they were looking for. And you can see in 3, 4, 5, and 6 that as they increase pH to a more neutral environment, that you no longer see the structure that you wanted to see. So, again, it's going to take a lot of experimentation to, figure out what is the optimal condition for your specific sample. And just to refer back to our list of common negative stains, you can see they all vary quite a lot in pH. So again, take that into consideration when you're planning your experiment. So here, that's all we have to say about negative staining. Again, hold your questions for a minute. I'm going to talk briefly about returning to the lab and just being safe. So we have established some protocols. Yes, we are taking samples, COVID samples, but we are not a BSL-2 or BSL-3 facility. So absolutely nothing live. Please communicate with us. Don't just show up with an infected COVID sample. We really want to make sure that we know what's happening ahead of time. Everything that we receive must be fixed for at least 24 hours in glutaraldehyde to deactivate the virus. Please disinfect the outside of the tube as well. But just want to say out there that we really do want to help. We would really love to look this thing in the eye and assist in research any way we can during this pandemic. So we've established just some protocols to try to keep everybody as safe as we can. If you're going to access the instruments in AB, if you're looking at the BioCryo 7700 or any of the EPIC instruments, they are only accessible through the elevator on the first floor. So the back stairs and the side stairs are not, they're locked. In Hogan, it's a fairly large room, and we do have a lot of equipment in there. We've got the critical point dryer, the high pressure freezer, there's a bunch of bench space and a hood. So we do have room for up to 4 people in the Hogan 5150. In Silverman, it's a little bit more tight. In B555, I have my bench there, and there is the workstation for accessing data. Technically, there are 2 people allowed in that room, but if you're over by the bench, that's really it, just one person over there. So if you're there and you see a couple of people come in, feel free to flag them down and say, hey, no, people do come in to use the negative 80, the minus 80 freezer in there. Please make sure you're wearing a mask and gloves at all times on the instruments. I know it's not fun, but we really want to make sure that, if we have just one case, we're done. We have to shut down. So please wear your gloves and your masks while using the instruments at all times. And then when you're done, and if you're not feeling comfortable, you can do it at the beginning too. Feel free to, not feel free, please do wipe down all areas. So we've got paper towel in there, spray it with some 70% ethanol. Make sure you wipe down all the high touch areas. So don't forget about, like, say, if you're using the TEM holder, just the handle of it anyways, not the rod. Doorknobs, light switches. We have the keyboards and mice wrapped with saran wrap. So we are periodically changing that out, but you can also wipe that down as well. And so that will keep it safer in case we're not able to get in there right away to change it after your session for the next user. we are controlling all reservations at the moment. So this may change relatively soon. I don't know. It's going to depend on when we plan to introduce the next phase of opening. If things don't change too rapidly, it's always we're always watching the numbers. But we do ask that you request 2 days in advance if you're going to make a reservation. We will happily book that for you. Keep in mind, you might not get the exact slot you need or that you want, because we do have to have a half hour between sessions to let it air out, to give us a chance to clean if necessary. There are the workstations where you can grab your data, but we would prefer to keep those as unoccupied as possible. So if you're able to, please use your smartphone to start your reservation on the new course system. At the moment, we are not doing trainings. We are experimenting with some maybe remote training possibilities right now. But as far as social distancing goes, you know, there's, especially if you look at some of the rooms, like where the HD 2300 stem is located, you can hardly fit 2 people in there to begin with, let alone for a training 6 feet away, showing you how to use the apertures and everything. So unfortunately, at the moment, training is just not possible. But we do hope to implement that as soon as we can, and we really want to get you on the microscopes. If you have a project that you really need some data for, we ask that you maybe work with another member of your lab who's already proficient with the microscope, or feel free to contact us, and we can provide service for your sample and gathering images for you. Try to follow the traffic signs if you can. As far as going down the hallways, I know that's kind of annoying, right? Like if you want to go this way and there's somebody coming, kind of back up against the wall. But just keep as safe as you can. Follow common sense. Wear your PPE, and hopefully we'll all get through this together. So at this time, I'd like to thank you all for attending the Tech Talk. We'd like to open it up for discussion at this point if you have any questions. So feel free to chime in. See, I'll open the chat here and see if anybody's asked anything in the chat.
We have to unmute people.
Where is my chat? Yeah, so here's the chat. Okay.
Are you able to unmute? Did you unmute? Okay. Unmute the group.
Yeah, people can also unmute themselves.
Okay.
Okay, so the question was raised. Sophia, thank you for asking. Yes, the slides will be available after the talk. So yeah, we have a lot of references in there, so you'll be able to access that. The talk also is being recorded, I think, and will be available online, barring any technical issues with Zoom. So thank you for asking that, Sophia.
Nuance, I think, has a page that has the Tech Talks. So it would be introduced, you should be able to access it through that for sure.
Yeah.
I'm not sure if I will have
Yeah, we'll either have it on the Tech Talk page, and we also have a YouTube channel, which I'll post on the YouTube channel. And when I send out the survey, the post-event survey to everyone who registered, I'll include a link.
All right, Charlene, you want to take this next one? Jessica Walker asked, how should we dispose of excess uranyl acetate?
So how much is excess? When we're, so we have, and I don't remember I actually said it or not, but we have an area in the 5150 where people are doing some negative staining, and there are containers for the solid waste or things that have come in contact with your UA and such. So a larger container, and then we have a container for liquid uranyl acetate. As for like excess dry, like the crystals, and I'm sorry, I'm just gonna see if Jessica clarified anything. No, okay. That would actually, I think that you'd want to actually go through research safety, and if it's excess containers of it, they should have a way to do waste. We've had a lot of kind of changes in the way research safety has been addressing uranyl acetate, uranyl formate.
Yeah, just in the last like 6 months or so, they've changed everything, I think, on us.
Over the past 10 years, they kind of change it all the time, right?
Yeah, that's true.
So we're trying to get work with them to find out just how we're going to move forward with that, if we're going to allow people to do that in our space. But usually you'd have to do a liquid waste container. If you're talking about even in your own line, they have liquid waste container, and then you'd submit a form for pickup of radioactive waste.
I do have liquid waste in the hood in B540. We share that hood with Cubic. So really there's minimal usage in there. You know, if you're doing negative stain, hopefully you're using 5-6 microliters at a time, you know, so really minimal volume of waste. So hopefully we can just keep that down to a minimum.
Yeah, but if you have a container and it started to precipitate, you can have a couple of mLs and you need to get rid of that waste. So I'm wondering if that's also what she's talking about, right?
Yeah, for sure.
But you're right. We don't use large volumes of it in general, right? Charlotte Chen is asking, what is the least toxic negative stain? If they all work, the only thing
Yeah,
I
sure.
agree with,
you know, UA is super depleted, so it's you know, it's not throwing out tons of rads, but that definitely is a concern. You know, there are a lot of less toxic stains out there. Platinum blue is a newer one that is recently available commercially, and it utilizes platinum, so it's not quite as toxic. As I mentioned before, there's like ammonium molybdate. You know, obviously we want to stay away from any lead-based stuff, so we're not doing any lead staining for negative staining anyways. Yeah, I mean, if you can stay away from uranium, all the better. And there are a lot of commercial ones out there too, available through through nanoprobes. Through EMS, you can get a lanthanum-based stain, which is kind of an interesting. I played around with that. Again, contrast is not as high, but there are a lot of options out there. So Charlotte, if you want to discuss that with Charlene and I later, we can absolutely investigate that further for you. I don't know exactly what the least toxic one is, but we can try to figure that out. Next question is, what grids or stain do you recommend for immuno-TEM? So that's a good question. So, you know, it depends how long you're incubating, right? Your antibodies, your primary antibody. I definitely never use copper grids. You can definitely have an interaction there, especially if you're incubating overnight. You know, you'll come back the next day and you'll see your droplet is green. So that's no good. I, for immunolabeling, pretty much only use nickel grids. You can use gold as well. I haven't, but you know, because it's a little bit more expensive than nickel. But they both work pretty well, I believe.
Yeah, I think they have them made up, pre-made, coated gold or nickel grids, but also you can always make your own grids. So if you have gold or nickel grids, you can always create a carbon or a former coated grid yourself. It's a fairly easy technique, but so you can either purchase them or create it yourself.
So for stains, for immuno, you just want to make sure that your stain is physiologically compatible. So, you know, could use something along the lines of a, you know, neutral pH ammonium molybdate. There was the methylamine tungstate, which I believe is also compatible with some immunolabeling. So yeah, thank you, Hank, for that question, because there is a lot of experimenting left to do, a lot of things left to discover, combining negative stains with immunolabeling. Romain, can we use acidic staining reagents, including UA samples at pH 7? Okay, so yeah, that's a good question. If you're using, like, you know, uranyl formate, that you can't have that above a 5. That breaks at 5. Charlene, you've experienced that quite a bit with trying to make that up, or yeah. Oh, so you're saying, but the samples are at pH 7. So, I mean, it depends on your sample. You know, if you've got any issues in there with, you know, biological samples, you know, PTA can work with some viruses, but it will also disrupt some viruses and some membranes. So it's going to take some trial and error for your specific sample. Hiro, can you mention a bit about other contrasting agents such as osmium? Oh, I'm looking to see if anyone has dedicated hood for such processes. We do not have a dedicated osmium hood, but you definitely want to be careful with osmium. If you're staining with osmium, typically it's in more of a vapor state as opposed to liquid state. There's another one, ruthenium red, for if you're staining polymers. Again, that's done in a vapor state. So no, we don't have any dedicated hood space for that. But if you can make up your little moisture chambers for that with some Petris, it can be safely done in a hood. That sounds really interesting. So Hiro, hit me up later about what you want to stain with osmium. Thank you. Dieter, speaking of less toxic stains, to what degree would you work with solutions, some very simple salt solutions, say a transition metal chloride, as long as we have a high Z metal in it? That is a good question, and I cannot answer that, Dieter. I'd have to look into that. You're unmuted if you want to say something about that.
Oh, I was just curious. I'm completely new to this method, I mean, obviously there must be a reason why we use the acetates and these more complex salts. I was just wondering, and I think people probably must have tried this, and there must be a reason why it's not working. It almost sounds like it's too simple to be true. I was just curious what would happen if I tried.
True, Dieter. It is a very simple technique. If you're mixing up uranyl acetate, it saturates at 3%.
Yeah.
And then you get precipitate, and if you let it sit for a while, even at 1%, sometimes it precipitates out after a while. So as far as what it's being dissolved in, and also this is just what's available commercially. So you buy your uranyl acetate powder, right? So it's not, you can't get it in the other forms very, very readily. Charlene, you want to say anything about that?
No, no, I agree. I'm not. Yeah, and I'm wondering. Yeah,
Brian,
I'm not.
Do you know?
It might be a question of getting the solution right to that point where it starts precipitating, and I could think with something, let's say iron chloride or something, it might be much more difficult to keep the solution right at that point where it starts to precipitate. Just a guess.
That is a good idea, Dieter, but the point here is you need really very heavy atoms to get a good contrast, and that is why uranyl is still one of the favorites there. So with zinc or iron, I think your contrast would probably not be sufficient.
Yeah, that's a good point. You do really want a high Z number element in there to take for the electron beam to interact with, to give you more inherent contrast.
Yes.
And grain size maybe, where it's just.
Yeah, there's I'm seeing papers out all the time with different stains that I've never heard of before too. So people are experimenting a lot with different things, Dieter. So if you have a sample that you'd like to experiment with, feel free to bring it to our attention. We would love to work with it and figure out what the optimal parameters are for it.
Sure. I was just curious. Thanks so much.
Yeah, thank you.
Thanks for the question.
Okay, so thank you for bringing your questions about negative staining. Does anybody have any concerns about safety in the lab for our new safety protocols or COVID? Anybody feel uncomfortable? We want to help. We want to hear from you if you are at all uncomfortable, or if you see something that you're going, hey, some red flags are going off my head. I'm not safe in this room, or something's going on.
And be aware that the situation is fluid, and we will send out notices to people when we do change our policies, either creating more access or restricting access, depending on, I would say, activity levels of viral infection, right? Infection rates.
Keep in mind, Illinois is moving to phase 4 on the 26th. That does not mean we are. So we maintain control in our labs, and so we're going to keep them as safe as we can. Illinois is doing great. Our numbers are way down, but other states are shooting up, right? So we are watching. I watch these numbers every day, so I really want to make sure everybody is safe, and I want to make sure that we can continue to do our research safely and really contribute to all research. All right, so if there's no more questions, then I really want to thank everybody for chiming in today and participating and listening to our talk. If you do have any questions that maybe you weren't comfortable asking, feel free to email Charlene or I or Reiner. We want to help. So thank you again. Oh, there's a poll going up here. So please fill out that poll. That'll really help us, actually. I'll just leave this up here for now.
Well, thank you very much. It was very useful.
Thank you.
Oh, good.
All right, bye, everyone.
Bye.